Good morning, everybody. Welcome to our technical workshop today. Today we have the pleasure to present to you the talk titled Summary Prospectivity of the Sinu Guajira and Colombia Offshore Basins, organized by la Universidad de Caldas, Universidad de Pamplona, Universidad Nacional, and also the ANH also. Well, this is at the beginning of the last cycle in our workshops before our round 21 summit on November 17. I have here the plan for the workshops of the complete or part of the cycle until October 8. I will announce the others in following talks. But today we have the pleasure to talk about the offshore in Colombia. We will try to summarize the prospectivity of the Sinu offshore, Guajira offshore, and Colombia offshore. And those talks are going to be given by Angela Navarrete, Dr. Juan Carlo Ramon, and Dr. Ruben Arismendi. And the closure of the talk is going to be given by Cesar Mora, that you know very well. I mean, so we were trying to talk about the seismic aspects and the potential traps there. And at the end, we were trying to cover all the petroleum system topics in order to conclude that we have both the thermogenic and the biogenic origin for the organic matter there. Okay, I'm very happy to announce that we are going to be very aggressive in this cycle, and aggressive in the term of showing you as much as we can before the end of the deadline of the round 2021. And we will start next week, August 27, with all the interpreters of the agency are going to present to you all the cases that we have for all undeveloped, already discovered reservoirs. So we will cover all of them, total of 40 that we have in our list, in our files. And we will start next week with the Sinu San Jacinto, the one that are present in the Sinu San Jacinto, Lower Mac, and Middle Mac. The following week, on September 3rd, we will have all the opportunities in undeveloped, already discovered reservoirs on the Llanos. We have a big amount of them there. On September 10, we will have a break because we have a very interesting and special speaker, and those are the group of ION. That group is going to talk to us the new. They are going to show us the new reprocessing that they are doing in the Caribbean. So it's a date that we already selected with them, September 10, and we will. There are very interesting findings with the new reprocessing that ION is doing in that part of the country. And we will continue on September 17 with also with the undeveloped, already discovered reservoirs. And we will complete the Llanos area, the one that we have identified in the Llanos Basin. And on September 24, we will mention to you the Upper Magdalena and the one that we have identified in the Upper Magdalena and in the Catatumbo Basin. On October 1st, we will have the special speaker. We will have Dr. Alejandro Mora, from Hocol, and he is going to give us the interesting talk, origin, evolution, and petroleum systems of the Lower Magdalena and San Jacinto Basins, Northwest Colombia. And in October 8th, we will have here the Geological Survey group talking about prospectivity in the Paleozoic rocks of Colombia. Okay, so something that I forgot to mention is that in addition to talk about these undeveloped, already discovered reservoir, the agency will try to show to you the geology and the prospectivity of the six blocks that have been already nominated by the industry, in addition to the 28 that we have already in our list. So we will have a total at this time, we will have 34 blocks being offered to the industry. And as I mentioned before, 28 have been offered by the agency, and 6 have been nominated or incorporated by the industry. And those ones, the interpretation of those ones, the interpreters of the ANH are going to show to you those ones as well during those talks in the following weeks. From October 15 to November 17, in that month, we will close up all our efforts. We have especially special speakers. I mean, we will have one section on October 15 related to the research project that are in progress with the MinCiencias and ANH. So we will show to you those projects in one section, October 18. On October 28, we will continue with the prospectivity in the Paleozoic in Colombia. And on October 29 and November 5, we will show to you the other aspect of the prospectivity in the Caribbean, the other findings that ION have done on the Caribbean. So we'll have a couple of sections on October 29 and November 5th. And the last section of those workshops will be a summary of everything that we have done during the year. As you know, by that time, we will complete almost 30 workshops given by the agency during this round 2021 promotion. Okay, then don't forget that the oil summit is on November 17 as part of the Petroleum Congress, so we will be there. Just to mention to you that the importance for the agency of showing to all of you all these undeveloped, already discovered reservoirs. I mean, you have here in this map, in green color, the places where we have identified those opportunities. And you see there the reserve that we have quantified for all of them. And in red, you see the ones that are part of the blocks offered by the agency as part of the round 2021. So in green, those opportunities are in open acreage, available for you for nomination by the industry, and in red are the ones that are already included in the 28 blocks offered by the agency this time. So don't forget, I keep telling you every week that we are working very hard in establishing the process to start the support, the economical support for students on last year's thesis, and also students that are graduated. I mean, we are establishing those processes to support them on research studies on frontier areas, Caribe, Choco onshore, Choco offshore,
Miguel de Armas.
Sí.
Ah, pero él medio lo machaquea.
Excuse me, can you? We have one microphone open. Okay, thank you. We have the Cauca Patia as well, the Caguán, the Cordillera. Okay. Well, I have today the pleasure of having very interesting speakers today. We have Angela Navarrete. She is representing the Universidad de Caldas, and she was graduated in 2002 from the National University of Colombia. She is a Master of Science of Geology, also from the National University in 2006. And she has had more than 15 years of experience with Sea Petrol, Pacific Rubiales, and Frontera. Welcome, Angela. It's a pleasure for us to have you here. We have Dr. Cesar Mora. Now we are mentioning Cesar at the beginning because last time I missed his name and he was a little bit upset with me. Cesar is graduated from the National University in 1997. He is a Master of Science from the Federal Universidad de Rio de Janeiro in petroleum systems in the year 2000. Cesar has more than 30 years of experience. He has worked for Ecopetrol, Cipetrol, HEMS, and Cuenca. We have also the pleasure to have here Dr. Ruben Arizmendi, graduated in 2002 from the National University of Medellin. Graduated Master Science 2008 in Holland in basin modeling and petroleum system. He also ran an MBA in oil and gas management in 2014 in Scotland. He has more than 15 years of experience and has worked for Trajectoria, Integral, EMP, and he is the owner and general director of Neo Oil and Gas. And we have the pleasure also to have Dr. Juan Carlo Ramon with us, graduated in 1988 from the Universidad Industrial de Santander, UIS. He is a Master Science from the Colorado School of Mines in Geophysics in 1994. He is a PhD, a doctor in geology as well from the same university, Colorado School of Mines in 1997. And he has more than 28 years of experience. He has worked for Competrol, BP, Arco, Emerald, and currently he is acting as an advisor for the Geological Survey of Colombia. Okay, so as I said before, we are just in this talk summary, Prospectivity Sinu Guajira and Colombia Offshore Basins, Unicadas, Universidad de Pamplona, Universidad Nacional. We will start in the following order. We will cover Sinu Offshore by Angela Navarrete. We will continue with Dr. Ramon, Juan Carlo Ramon, Guajira Offshore, and Ruben, Dr. Ruben, we will close with the Colombia Basin. And Cesar will tell us about the petroleum system and the system of thermogenic and biogenic evidence on those basins. Welcome, and Daniel Rodriguez, we will continue in the close-up of the workshop. He will be addressed. You can address all your questions through the chat, and Daniel will answer or coordinate the answers at the end of the talk. Thank you very much. Angela, in your hands.
No se le escucha. Okay.
Yeah. Okay, so then welcome to all of these workshops. I'm going to start presenting the results of the seismic interpretation. What happened? It's not working.
Clic sobre la presentación y ya va.
Yeah.
Okay.
Okay, so I'm going to present the results of the seismic interpretation from the project Geological Integration, Petroleum Systems and Prospectivity of the Colombia's Frontier Basins, Sinu Offshore. In the agenda, we have a general information, available data, some of geological framework and stratigraphy, seismic well type, geological provinces in the Sinu Offshore Basin, areas of exploratory interest, and conclusions. So the Sinu Offshore Basin is located in the Colombian Caribbean Sea. It has approximated area of 29,000 square kilometers and is bordered to the northeast by the Santa Marta Bucaramanga fault system and the Oca fault system. That separates from the Guajira Offshore Basin. To the west, it borders to the Abyssal Plain of the Colombia Basin, and to the southwest, it limits with the Uramita Fault that separates from the Urabá Basin, and to the east with the coastal limits of the Colombia, and that is the Cuenca Sinu San Jacinto. From the available data, the Sinu Offshore Basin is covered by a fairly extensive 2D seismic. The density of the information coverage is regular and maintains an homogeneous pattern of distribution with preferential orientation in the northeast to the southeast deep lines, and with spacings that range from 5 to 10 kilometers. The 2D seismic programs available for this study were acquired from the second half of the 1970s to the present. For this project, we use a total of 624 2D seismic lines, equivalent to almost a little bit more from 42,000 kilometers. And also we use two 3D seismic volumes, Magdalena and Bahia, equivalent to more than 4,000 square kilometers. Additionally, we have information on 18 wells drilled in the basin between 1969 to 2015, which were used to tie up the control to the basin chronostratigraphic framework. And also we use the well ODP 999, that is a drill in the Colombia basin, but it permits us to tie up the pre-Miocene units to the basin. From the tectonic setting, we have mainly the Caribbean plate. According to the movement of this plate, we have the effects on the edges of the same, and is characterized by the construction of limits constituted by sinistral tear faults between the Caribbean plate to the North American plate, dextral tear faults between the Caribbean plate to the South American plate, some convergent limits in the subduction zones in the eastern limit of the Caribbean plate and in the Central American zone, and divergent limits defined by extensional zones like in the Cayman Throat and Beata Ridge. From the stratigraphy, from the 18 wells that we have drilled in the basin and that were available for this study, we have three that are the most important. The first one is Calasu, the most recent in the information that we have, and also the one that has drilled the greatest depth in the basin with more than 20,000 feet. But this well just reached the deepest part, in this deepest part, the late Miocene sediment. The other well is Arasa 1, the only one that in the basin that has drilled the oldest section, reaching the late Oligocene at the depth of 13,390 feet. And the other important well is the ODP well that is located in the Colombia Basin, but it was used to tie through the undeformed section, allowing to bring all the phases and intervals from the Miocene to the study area in the Sinu Offshore Basin. Okay, so from the seismic well type, from the chronostratigraphic peaks that we use, we have the information available from biostratigraphic, bibliographic, modeling reports, and other analysis obtained by the Stratigraphic Research Institute in the University of Caldas. Once the synthetic seismogram of the Calasu well had been carried out, and the well type was evaluated with the seismic reflections, we decided to interpret three horizons that is defined in this way. The purple one is the Miocene, late Miocene, which is a reflector of regional station in the basin. And the other two horizons that we defined from this well was the late Pliocene 1 and late Pliocene 2, the green one and the yellow one, that corresponding to reservoirs intervals in the basin, depending on the Calasu results. The horizons selected in the ODP 999 to be interpreted towards the Sinu offshore and that we identify in this well, and that could interpret out towards the Sinu offshore, were the late Miocene top, the late Oligocene, early Eocene, early Paleocene, and late Maastrichtian top, and the basement. Also, this well did not reach the basement. In this area, is easier to define its seismic character to correlate it to the Sinu offshore basin. Finally, with the seismic horizons brought to from the Colombia Basin and added to the horizon selected in the Calasu Offshore Basin, at the end we had 5 horizons that we established in total to interpret and make the mapping for the area of the interest. So from the base to, from the base to top that we interpret in the Sinu offshore basin, we have the basement, the late Oligocene that will be this blue one, this one correlated from the ODP area, and the Miocene, late Miocene, the purple one, the green one, and the yellow one, the late Pliocene, the Pliocene, sorry. We generate several transects throughout the basin that includes the wells and the time depth time that cover the entire basin and the 5 horizons of interest. These transects were taken and starting the point in the total interpretation for the events and main structural features of the area. The interpretation of the horizons in the seismic section that did not have well control was based mainly on the correlation of their amplitude and continuity characteristics. The horizons in general that we could have in the Sinu offshore basin, there are in some areas they are continuous, but in some areas they could be eroded by a lot of unconformities that could be checked, and a gradual also appears in a gradual thinning to the offshore and to the Colombia Basin. Okay, so with these 5 horizons, we start to define some geological provinces in the Sinu offshore basins. As part of the main features identification processes, we create simple and composed sections to establish the structural configuration throughout the different geological process. So in this cross section that we have from the southern part to the northern part of the basin, the main structural features can be observed in a general way, where from the south we could correlate completely all the 5 horizons through the basin. It can also, and we can see the different areas like this, folded truss belt of the Sinu, the Abyssal Plain, the Delta del Magdalena, and the fold truss belt in the Bahia area to the north. It also can be seen that towards the southern part of the basin, in the area of the fold truss belt, the basement is close to 6 seconds, but to the north, it gets deepest until to reach more or less 10 seconds in the seismic sections. These changes in the thickness and the geometry of the reflectors they are indicative of the difficulty in interpreting the pre-Oligocene sequences in the basin. Mainly in this sector, since the quality of the seismic data and the small sedimentary thickness between the Oligocene and the basement reflector, it was impossible to interpret an horizon associated with the Cretaceous age in this area of the basin. In this work, the entire sequence below the Oligocene can contain these units, but with low thicknesses, since the space of accommodation and the paleography maps apparently were the ones that determined the distribution of the oldest deposits. Okay, so I'm gonna start with the provinces that we define. So first one is the Abyssal Plain that is in the front of the basin. These provinces is located in the western limit of the Sinu Offshore Basin. In this line span, located in the southwest part of the basin, a thick undeformed tertiary sequence is observed, and that is characterized by presenting reflectors with parallel to subparallel patterns. They are very continuous that extend towards the Colombia Basin and to the southwest of the basin, sometimes make onlaps on the late Miocene in this area. In the higher phases, it presents some seismic responses associated with channel events, channel complexes, and even mass transport complexes. For the basement and the Oligocene sequence, and we observe an extensional deformation with the development of normal faults that generate gravens and horsts that with predominant northeast, southwest strike that control the deposit of the Oligocene and the pre-Oligocene sequences. For the province Sinu Offshore Thrust Belt, this province is characterized by a zone of compressive deformation with significant shortening resulting in a complex system of imbricate thrust with faults with complicated syndepositional patterns also, and a lot of unconformities. The imbricated thrust system involves the Miocene to recent sedimentary sequence. The main structural elements that characterize this province are the associations of faults, mainly fault propagation faults, fault bend faults, the thrust faults, and also the presence of mud diapirism. This province of Magdalena Delta, this is located in the central area of the basin, and it is possible to observe some seismic characters that indicate the compressive deformation associated with the accretion prism, but in which the faults could not fully develop their structural relief due to the high sediment load contributed by the Magdalena Delta themselves, generating an anticlines that they are really broad and smooth in this area of the basin. And the other province is Bahia area. It's located in the northwestern sector of the basin, and there is a deformation of the lower thrust density. Once again, showing structures associated with accretion prism, similar to those that occur in the south area of the Sinu Fault Belt. A series of thrusts is developed with a divergence towards the northwest, generating symmetrical faults in the deformation front in this area. Towards the northwest to this area, the faults become more and more asymmetric with more deep faults, and starting from an increasingly deep of the detachment. So the detachment is getting deep, and this reaching a zone of a strict slip faulting generated by the transtensive forces that develop negative flower structures and subsequently suffer transpression. These forces causing the local lifting of blocks like it occurs in the area of the Arasa block. Okay, so now from the areas of the exploratory interest, we propose the following dominant plays, which are defined from the poorly closing criteria. This shows the distribution of the dominant plate in each area. It means that we have seven different plate types within 5 areas of preferential distribution of closures that are genetically related. These plates are the formation front in this area, in the front of the thrust belt and in the front of the thrust belt of the Bahia. The low relief structures with the stratigraphic component, mainly in the front of the basin, the thrust belt anticlines, the intraslope basins, and the shale mobile related traps that are related to the folded belt, and channels in low relief structures that are mainly related to the Delta del Magdalena, and some stratigraphic traps related to unconformities that we could identify in the Bahia area. Okay, so now we are going to show you here. Okay, so we start with the deformation from toe thrust. This play is located in the most frontal part of the structures of the fault thrust belt, in the footwall of the last thrust, so in the frontal thrust, and have closure in the other direction, in three-way and four-way closures. On the map, it can be observed these green stripes that extend from the southwest to the northeast in the sectors of in the front of the thrust belt and in the area of the Bahia deformation front. The main risk for this kind of play is that the closures are between the Colombia Basin and the Sinu Offshore Basin. So it should be well defined in the limits of the both basins. And also it could have sometimes it could have problems with the closures directly to the fault. For this play that is the most extensive in the area, we present these maps that we made to the upper Miocene. These are the higher closures here, here, and here. For the sequences that we interpret in the Pliocene 1 and Pliocene 2, we also find some closures even in the front of the Sinu offshore, and some of them can be seen in the limit with the Cuenca Colombia. And this one also we can see the closures by the Pliocene 2 levels. Okay. Also for this type play, there are sectors where we can identify a greatest amount of seismic anomalies, that especially flat spots associated mainly with the Miocene and Pliocene intervals. That indicates that could be good indicators for the presence of hydrocarbons. Okay, low relief structures with the stratigraphic component play. So this play is associated with the structures of the Abyssal Plain. They are more proximal to the in the area of the Sinu offshore thrust belt. This play is characterized by having a four-way closures presenting limited hydrocarbon columns. They have large closure areas, and it's possible to have different contacts in multiple layers. This is due to its stratigraphic component, which given its position in abyssal plain environments, these reservoirs are favorable for turbiditic deposits in unconfined environments. So the main item is that the closures mainly are in the Colombia Basin, not precisely in the offshore Sinu Basin. The thrust belt anticlines. In this play, with the is the one with the greatest distribution and presence in the area. This is made up from dominant closures, both in the Sinu offshore thrust belt here in this area and in the Bahia front deformation. It's represented by sediment from the light Miocene to the Pliocene, which are strongly folded and thrusted. This play is represented by anticlines with four-way closures, three-way closures mainly. In this map, you can see the series and all the map, the anticlines for this, and also some of them, they have the complete closures. But the main risk for this play is the retention due to the rupture of the structures, and also for the presence of the shell diapism that could broke even the traps. So this kind of play is so interesting with a lot of structures, but they should be really well defined in the closures. The next play is the Intraslope Basins. This type of stratigraphic or combined traps are sediments that were deposited in the so-called intraslope basins. These basins are typically formed within the slope as a result of localized removal of substrate, which can typically be shale, but can also be related to structural movements, syntectonical movements that occur during the folded belt formation process. In areas where there is movement of shale, they can produce ponded basins deposits, and they take a form of long linear synclines located towards the rear of the folded belts, or within the hanging blocks of the anticlines. The main risk for this kind of play is the quality, the distribution, and the continuity of the possible reservoirs in these areas. The other play type is the shale mobile related traps. This play was not geographically separated because it shares the aerial distribution with the thrust belt anticline. It's known that there are similarities between the architectures generated by mobile shales and the saline or saline units. Both materials are mobilized, providing traps and hydrocarbon migration paths. However, there are significant differences in the natural distribution, timing of the movements, and active processes in the shale-based versus salt-based systems. Sometimes they are not completely understood. But that's why in this study is proposed as a play with high risk. But if we could have a better understanding of this, it may have great potential given its wide distribution throughout the basin and its relationship with the numerous hydrocarbon indicators that we can find also in onshore basins and offshore basins that are associated with the mood diapism. For this place, so we need a better quality for the seismic data. And the main risk could be the retention related to the shell mobility and the seal of the traps. Okay, the next play is the channels in low relief structures. This play refers to the gas discovered made in Cartagena 2 and Mapale 1 wells. These wells were drilled reservoirs associated with canal systems and channel lift complexes from the late Pliocene, both located, both located in slope environments. This plate is located mainly in the area of the greatest influence of the Magdalena Delta and can be considered as a proven play, even though the discoveries of the wells mentioned have not been developed. The stratigraphic component in this type of plays of the great importance, since being a combined trap, is necessary to understand the geometry of the bodies, their distribution and extension within the areas with possible closures. This implies that for a correct definition of the trap, it's necessary to have 3D seismic information for the identification, mapping, and distribution of the reservoirs, as well as the use of seismic attributes, especially spectral decomposition, that help reduce the uncertainty associated with the presence and definition of these bodies with a structural closure. So the main risk for this kind of play is the continuity of the reservoir. The next play is the stratigraphic traps related to unconformities. This play we identified in the area of the Bahia sector, and they are described as stratigraphic units that, due to tectonic processes, they found in shallow intervals and that have been affected by erosive events generating stratigraphic traps, like in this area of the Arasa well. This type of trap is highly complex and risky, given that it is necessary to understand the distribution of both over the reservoir and also the overlying rocks, which should be characterized as an excellent seal that generate an effective trap. For this reason, to reduce the uncertainty associated with this play, it's necessary to also have the 3D seismic information, well information, and analysis of attributes that involve the results of wells drilled in the area. So despite the results obtained by the Arasa well, it's not a good idea to punish the complete potential of this area. It's important to have in mind that Arasa has been the only well in the basin to drill the Oligocene section. And thanks to that and to its results, we can propose different geological and structural scenarios that were not thought for the basin before. So I think that the Bahia sector is still poorly understood, and it's possible to propose that this area in the northernmost extension of it could be the northernmost extension of the San Jacinto thrust belt, which could imply the presence of all the rocks in the sequence of what has been observed in the Sinu offshore. If we consider this hypothesis, the Bahia area will even have the potential of the presence of light hydrocarbons, as happens in the onshore in the San Jacinto thrust belt. Because in the onshore sector where the Eocene and Oligocene rocks that are generating this type of hydrocarbons has been preserved. So therefore, if we have a better understanding of the Bahia sector, its geology and integration with geophysical information, the result of that could change the paradigms of this specific sector in the basin. So as a summary, so we identify 4 geological provinces in the Sinu Offshore Basin with a lot of potential. That is Abyssal Plain, Sinu Offshore Trust Belt, Magdalena Delta, and Bahia area. And in that ones, we identify the 7 plate types: the formation front, low relief structures with a stratigraphic component, thrust belt anticlines, intraslope basins, shale mobile related traps, channels in low relief structures, and the stratigraphic traps related to unconformities. So that's all for now. Thank you to all. Hello.
Sí, we will continue with the Dr. Juan Carlo Ramon.
Okay, good morning, everybody. Can you hear me clearly?
Yes,
And can you see the screen?
yes.
Okay, perfect. Okay, hi, everybody. Welcome to this series of presentations about the offshore in Colombia. In the next couple of minutes, what we would like to share with you is the geological integration and basically with focus on the prospectivity of the Colombia's frontier basins. In this case, we're going to cover the Guajira offshore. The area that we analyzed with a team of
Carlo?
around 15 people.
Excuse me, Juan Carlos, could you put the presentation big, please?
Is in full screen, supposedly.
Okay.
Hold on. A ver, espérame, quito aquí la otra pantalla.
Perfect. Now it's working. Perfect. Okay.
Okay, good. Okay, so I was saying the study area is a huge area offshore, but we had a huge database, essentially composed of around 44,000 kilometers of 2D seismic and around 42 wells. Unfortunately, the wells are mainly restricted to the near shore area, and there are no deep wells in the area except by Orca. Based on this data and this interpretation, essentially we came out with several findings that we want to highlight. The first one is that the Guajira basin can be divided into 3 tectonic stratigraphic provinces that are clearly different in the structural styles and in the sedimentary evolution. The study area displays a complex tectonic history, mainly coming from the basement, and this distribution is restricted or constrained by the evolution and the convergence between the Caribbean and the South American plate. The basement, the evolution of the basement and the type of basement that we have in the Guajira area are very complex and are the result of overlap and accretion of different terrains through the tectonic history. And they were identified and of course they control the structural style that occurs in each of the different areas within the basin. One important feature is that we are interpreting the remnants of Cretaceous and Eocene sequences in several low gravens in the basin and depot centers, that they are important for the petroleum systems to work in the area. And we believe that these remains at these depot centers are closely related to the most exploration areas. Deposenters generated by the differential tectonic activity that we have in the area control the changes and the distribution of reservoirs. And one characteristic of the area is the close association between big deposenters and paleo-highs that constrain the migration path and the exploration pathways in the area. The presence of hydrocarbon shows in lots of the wells indicates or suggests that we might have active migration processes in the study area. There are good reservoir intervals throughout the basin, but we consider, of course, that the main targets will be the Oligocene and the lower Miocene sections. In the area, both stratigraphic and structural traps were identified, as we will summarize in the next couple of minutes, and showing that there is still a lot of exploration potential in the area. One important highlight is that the northern easternmost part of the Guajira Basin, onshore and a little bit in the offshore, is directly connected to the Gulf of Venezuela, where it is clearly documented the presence of the proliferous Cretaceous source rocks and associated to big findings in the Venezuelan side. The petroleum system modeling suggests that the Cretaceous source rocks in the area, in the deposenters, reach hydrocarbon generation and expulsion, as it will be shown later on. The petroleum system modeling results also explain the distributions of hydrocarbons that have been found in the basin, and we will show some evidences of thermogenic hydrocarbon manifestations that are evidenced in different piston cores and in some of the wells. The study area is essentially located in the northeasternmost corner of Colombia. Essentially, as you can see from this Bouguer free air gravimetry map, is characterized by a series of very deep deposenters, in here highlighted in blue colors, associated or closely associated with a series of paleo-highs that control the distribution of the sedimentation and the evolution of the tectonics within the basin. You might notice that we have a close association of the blue areas with the red areas that are the paleo-highs, the basement paleo-highs, that has a complex evolution and control the distribution of the reservoirs, the location of the remnants of the source rocks, and the development of the traps that occur both stratigraphic and structural in nature. If we take a look of this regional, almost east-west or slightly northeast seismic section, this section shows the complex history or the complex different tectonic settings that we have in the area. You might notice that toward the center of the seismic line, we have prominent paleo-highs, basement paleo-highs of different natures. And toward the left and toward the right, we have big deposenters. That is a pattern that is repeated in the area. And we have big deposenters that have a much higher or much better development sedimentation, including sequences from the Paleogene. As we mentioned, one of the promiscuous characteristics of the area is the presence or the close association of these big highs and these deposenters. This is an east-west to the seismic line in the offshore portion, way in the north, toward the northernmost corner, where you can see the big paleo high that we have in what we are calling the Tayrona province, and how it's closely related to a big deposenter that toward the right of the image that corresponds to what we are calling the Chimadi Province. these big changes in depot centers is a characteristic in the area that we believe has an importance for the exploration pathways. These are a couple of 2D seismic lines located toward the south of the area, close to the Cuisa and Oca faults. In this case, we are depicting here some of the how the ranging faults looks into the lines. They are characterized by creating low relief structures, but associated with some gravins that can preserve older sediments from the Paleogene, and in some cases, we believe they preserve Cretaceous strata. When we start walking through the different tectonic stratigraphic sequences that we propose, let's go and take a look of the Chirinche area that is essentially the southernmost part of our study area. This is a northwest line that is a deep line, regional deep line across the Chirinche province, showing the characteristics of the southern portion of the Guajira offshore. Essentially, the main characteristics that we have is that we have a relatively stable and quiet marine platform, very wide, with up to more than 100 kilometers wide. We have a very narrow fault thrust belt that in this case is created by the obliquity between this contact and the propagation of the Caribbean toward the east. And finally, we have the foreland basin, that's, as we may use the word, for what is called the Colombia Basin in the extreme left of this seismic line. The other tectonic important features that we might see in this line that are characteristics in the South Province that we call in this Chirinche is the presence of the block tectonics, that we have a series of gravins and horst in the basement that, based on the well-locked tie, we believe that in some of these gravins we might have preservation of Cretaceous sequences. This line, this one is essentially a north-south line, so a regional deep line across the southernmost part of the Guajira offshore. In this one, we see the same kind of features. It's a wide marine platform, rather stable, not so deformed, and characterized by block tectonics close to the basement, and as I said before, preservation of older strata in these basements. And toward the top, we have extensional deformation, but with wide anticlines, but not so tight. Toward the right of this seismic line, we might see the characteristic expression of the range faults that regionally control the deformation of this area. In this case, what we are seeing here is the branches of the Oca fault. This beautiful seismic line, that is again a deep line located in the southernmost part, or southern and westernmost part of the Guajira, summarizes the different types of plays that we might find in the area. In this case, we have what we mentioned before is the remnants of older sediments, what we believe we have preservation of the Cretaceous strata in these gravins. Closely or nearby big structural closures, in this case, simple anticlinal closures that might have a big exploration potential. We also have the presence of the older strata, mainly what we believe probably the main reservoirs will be in the Oligocene section and the lower Miocene, or see, yeah, lower Miocene, probably a middle Miocene, we have a possible on-lapse and development of stratigraphic traps associated up deep of these charged areas. Another feature, final, is the presence of stratigraphic traps, in this case associated to turbidite channels that are very, very common in the upper Miocene section. And they have been proven very prolific in other areas like in Guyana. Finally, if we move further out into the offshore, we see the development of these beautiful fault belts that have nicely developed thrust fault belts that have a huge potential. And some of those have been tested in the Sinu area as was shown previously. If we move further to the north, in the central part of the Guajira offshore, we see a change in the structure. And the main feature here is the ubiquitous development of basement highs or basement paleo highs. What you can see in this regional, almost north-south deep line is that we have this huge basement that get very close to the surface, and actually they outcrop in the onshore in part of this province. And they dramatically control the thickness and the extension of the older sequences. One important feature here is that the basin was subsequently filled during the Oligocene, and there is a big section and there are big areas concentrated along the migration pathways, as we will see further on, that has a huge potential for stratigraphic traps and for on-lap type of traps around these embayments on pinch outs or on-laps of all the Oligocene and lower Miocene section against these paleo highs. Also, as representative to the further offshore area is the presence of the fault belt, that in this case is much wider than the one that we have to the south, as it doesn't have so much imbrication as we've seen previously, but those are characterized by slightly more wide fault belts in the further offshore area. This other section, it's not moving. Okay, this section, this will be a regional deep section that goes along the central part of the area, what we call the Nacional province. And as we mentioned, is characterized by this relatively thin sedimentary section that locally gets on lap by the Oligocene sections, where we believe are the best exploration targets. Toward the northeast portion of this section, we have wells that evidence the presence of this Oligocene that we are interpreting in the area. And also the wells documented clearly the presence of thick Cretaceous sedimentary sequence. Also, given the fact that we have big and regional paleo highs, during the early Miocene, this basin was completely flooded. And during this time, all these basement highs were covered by shallow marine high energy sections that develop in a lot of places carbonate buildups, like the ones that we are seeing in this, beautifully seen in this seismic 2D line, where you see the nice develop of the carbonate buildups that consist of one of the main exploration targets in the area. Actually, almost all the production of commercial production in the Guajira comes from the Chuchupa field that is essentially one of these carbonate buildups. The other type of play that is very proliferous in this central part of the Guajira Basin, mainly in the shallow waters, are the horst, the remnants of the basement horst, given the block tectonics that we have in the area. And associated to this basement horst, we might have sandy onlaps in the surrounding sandy gravens, or we actually have carbonate buildups or high energy sandstone remnants of the mainly Oligocene in age over these paleo highs. This is another example of the onlaps sequence that we have. In this section, we beautifully show the huge onlapping sequences that are truncated against paleo highs or against paleo structures, from older faulting in the basement. And some of these features, as you nicely see in this seismic image, we might see that you can even see amplitude anomalies develop of some of the strata that is onlapping against these basement paleo highs or these basement older features. Finally, as we move toward the northeasternmost part of the Guajira Basin, is what we call the Chimadi Province. Here we have a dramatic change in the structure as compared to the previous unit. And this is a representative line in this northern part. What you can see here is again a very wide marine platform, very thick preservation of sediments. In this one is the biggest preservation, not only of Miocene, but from also Paleogene and Cretaceous sections. In this case, the Cretaceous section that we are depicting toward the right end of the figure, this section comes from a well that is nicely documented, and this section, the Cretaceous section, might contain the source rocks that will charge the different structures in the area. The other feature that we have, once we finish the wide marine platform, is less development and not so tight a folded truss belt toward the center part of this seismic line, and finally getting into a thinner section in the Colombia Basin. One of the features that you might note also in this regional line that is a characteristic of this province is the presence of, again, block tectonics in the basement that creates a lot of gravens and horst, where you can see not only control the migration pathways, but also the preservation of the different Paleogene and Cretaceous sequences. This regional seismic line is a strike line showing the character of this deposenter toward the north. Here we have a very thick preservation of sediments, not only the Neogene, but also a thick section of the Paleogene sediments in the tertiary, mainly Oligocene. We have a couple of wells drilled in this area, evidence thinner sequences of Eocene in age, and as I mentioned before, the preservation of a thick Cretaceous units in one of the wells. The main structural features that you see in this line is the development not only in the lower part of the block tectonics, but in the upper section, above the Oligocene, we have a very common and very well developed extensional tectonics, a lot of normal faults, in some cases listric in nature, and they are very widely developed in this part of the basin. This is a nice example of that. This is again a deep section in the northern part, where you can see, in this case, the San Jose well, that is one of the well that I mentioned before that has preservation of Cretaceous sediments that clearly document the preservation of those in this part of the deposit of the basin. And in the Miocene section, you see a very nicely developed series of listric normal faults that are very prolific, and these are a common play like in the Western Africa exploration targets. This is another example of this type of play in the area. As you can see, very nicely imaged by the seismic line, the tens of normal faults that you can see in this only seismic line. Here we might see the interpretation of the basement, the unlapping against the basement of some of the Cretaceous and Oligocene section, and over that we have the possible charge from these depositors. We have structural closures, anticlinal structural closures, and of course we have a lot of these closures associated to listric normal faults. And finally, as in the southernmost province that we just saw before, here again is potential for unlap stratigraphic closures. These are the regional seismic maps that we came, structural maps that we came in the area. In this one, we see the general pattern from the basement, showing the depositors located both in the south and in the northwest corner, and dominance of paleo highs in the central part. As we mentioned, one of the dominant features in the Guajira Basin is the close association of depositors to these paleo highs that will control the migration pathways and the development of the traps. Finally, the other type of trap that is a little bit deeper in the section is the ubiquitous presence of range faulting, but in some cases you might develop these beautiful positive structures that we consider also have potential targets, and some of these located further out from the fault belt have been tested in the south also, and consist of a structural potential for exploration targets. Finally, we have a secondary, what we consider secondary type of traps that are associated with these basement paleo highs that we mentioned before. We have also the development of and pinch outs of Oligocene sandstones over the highs. But we believe the size of these accumulations are not that big as the ones that we showed before. We have also the possible accumulations in the early Miocene sandstones over the highs, and of course, well, the secondary as compared to the carbonate buildups that are very very common in the platform areas, mainly in the Tayrona province in the central part of the Guajira Basin. And finally, we have in the block tectonics, we might have sandy fill outs in the gravens and in the pull-apart basins, or in the block tectonic gravens that we have preserved in the central part and a little bit in the northern part of the Guajira Basin. The sandy fillings and the gravens that we mentioned before, and of course the related unlaps associated with these to the sides on these gravens and associated horst Well, this is what we wanted to show today. You notice that we didn't cover the stratigraphy and all that we covered in the previous presentation, and in this one we focus mainly on the faults. So at this point, I will give the control to the next presenter.
Okay, thank you very much. Good morning, everybody. Please let me know if you can see my screen with a full presentation. Well, okay, I guess it's working. So good morning, everybody. Thank you for the invitation. Today I'm going to take you through Colombian Basin. We're going to see prospectivity of the Colombian Basin, why we think that is prospective, what information we have that actually is telling us something about prospectivity. So I want to have a look into this presentation in this way. First of all, what is the existing GNG data in the basin, what we have there, what we have analyzed so far, what we know about petroleum system elements from the GNG data. So we're going to from the petroleum system perspective, see what we have as a source rock, reservoir rock, seal rock, overburden rock, and trap, but everything from wells, the few wells that we have in the basin, and also the seismic that so far has been taken in the basin. After that, we're going to discuss some results or some findings regarding direct hydrocarbon indicators. Finally, we're going to show some of the plays that actually are giving us some insight of the prospectivity in the basin. So first of all, existing GNG information on the Colombian Basin. This is really important to have in mind, because when we think as a when we explore an area or a basin, we need to understand the detail of the information that we have. So some generalities about the basin. Colombian Basin is a deep water basin, part of the Colombian Caribbean, with an area of 2,600 square kilometers. It's a frontier basin with around 50,000 kilometers of 2D seismic and 61,000 kilometers of square kilometers of 3D seismic. This is the high resolution bathymetry. This is really important because I want to show you something. Basically, as you can see there, we got some highs. We're gonna see those highs. Why those highs are important in this talk, and we got all the development of the Magdalena Fan and the deeper part of the basin. So having that into mind, with the seismic that we ENH got so far, or the seismic that has been acquired in the basin, we got a good coverage of the area of the basin, as you can see, and some programs towards the border with shallower waters of 3D seismic. So that giving us a regional idea, especially in the deeper part, of how is the behavior of the basin. All this information has been in 220 study, integrated with gravimetry and magnetometry, also with geochemical data. We're gonna see that later with Cesar Mora, and a total of 8 seismic programs were used in this study. Yeah, and they were actually tied to Calasu 1, DSDP 153, and ODP 999. We're gonna see those wells in a bit. And also 6 horizons in total were actually interpreted: basement, Cretaceous, Oligocene, Middle Miocene, Upper Miocene, and Pliocene. Regarding the wells, we got few wells in the basin, as you can see. These wells actually are part of the deep sea drilling project, DSDP, that was actually done in 1966 by National Science Foundation and the Regency University of California. And another program was called ODP. This ODP was another program, a scientific program that was done in 1985. So we continue with those wells. As you can see, those wells are on the highs on the basin. So basically, we are on the flanks in the shallower parts of the basin where they were drilled. And Calasu is one well that actually was drilled right on the border between Sinu San Jacinto Basin and Colombian Basin. So we don't have wells in the deeper part of the basin. Again, some of the bathymetry. So that two red dots to show you that we actually are drilling in Kogi Kojaima Seamount, that is right here, and we also in Beata Submarine Mountain Range, and the other one is right here, that is Calasu. So this, in order to understand that we don't have much wells in the basin. However, those wells, the ones that are here selected, are especially DSDP 153 actually is drilling the whole sequence of reaching Cretaceous sediments, which is giving us the whole sequence, most of the whole sequence in the basin, and from there actually we tied our interpretation and seismic interpretation in the basin. So what we know about those petroleum system elements from this seismic interpretation. So from the source rock, basically we know that one of the main source rocks in the basin is the Cretaceous early Eocene origin. Basically, as I was discussing the last meeting, we got a basement, a paleotopography that is filled with late Cretaceous sediments, late Turonian. They are really easy to identify in the seismic. They are with typical wave shapes. As I said before, the SDP 153 actually reached the whole sequence in the Beata Ridge. And these sediments are basically calcareous rocks, marchalks, some volcanic sandstones, and foraminiferous sandstones as well. We can see the paleogeographic map, so we can see that basically during that period of time we got deep sedimentation, deep sediments in the entire basin. Here are some of that interpretation of the Cretaceous. As you can see, there are syntectonic sediments that are filling all this accommodation space creating but the extension and the rooting process. And also something interesting is that, well, according with available geochemical rock information, we're going to see that later with Cesar. I'm not going to go down the road, but TOC is 4.5%, and the average HA is 350, and thickness around 200 feet. So we got that as a source rock. Reservoir rock, basically we got also, we can consider also Cretaceous could be a reservoir rock, as we got some volcanic sandstone and foraminiferous sandstones. So that's why we actually think that it could be some kind of accumulation, especially in these flanks when they are filling this accommodation space. Additionally, we're moving then to late Miocene. Late Miocene is when actually is most of the contribution of sediments coming from the Andes is occurring, result of exhumed areas, and this is creating mainly structures that can be identified in the seismic, such as MTCs, canal leaf complexes, etc. Additionally, this is high acoustic impedance. It's easy to identify some of those structures in the late Miocene, despite we have no drill yet there in that areas, just Calasu, but it's easy to identify. However, the SDP 153 that is right here and 151 that is right here are showing us that in that high areas or elevated areas in the basin, actually we got deep marine environments, limestone, marls, and clays. So the most important reservoir were being deposited as result of the development of Magdalena River fan domain. This is some of the structures. Here we can see late Miocene sediments are easy to follow. As we can see, and on the top, we move into the southeast here, so increasing the sediments thickness, and also we move into the deepest part of the basin. We're going to see that later, and it's easy to identify some of the amalgamated channels and some high impedance reflectors that actually are overlapping on older sediments. Pliocene to Quaternary. Well, this is, let's say that when the Magdalena fan and Magdalena River has its major development. So basically on the flanks, the wells are showing as well as bathyal marine environments that are restricted to these areas, but seismic is showing us that in the central part, actually we increase sediment influx and we create more potential reservoirs. This is we try also to understand the Pliocene Quaternary behavior of the delta fan. So basically Pliocene is between 4 and 8 seconds to wait time. During this period of time, we get the most of the thickness. Again, we still have on the flanks of the basin deep deposits for deep environments. Some of the structure that we can identify, we can see clearly channels, levees, MTCs, etc. in the seismic along the Magdalena lower and upper fan. Also some other structures, some important structure. We can see high amplitude reflectors, some MTCs that are quite important. We're going to see that MTC later. Frontal splays as well along the basin. This is one of the lower abanico, lower fan of Magdalena, and clearly we can identify some of the reflectors showing the frontal splay. Regarding the slopes, this is showing us how is the current configuration of the Magdalena fan right now. As we can see, the main slopes are in this area, in the central area, when we believe that is the most important area for the development of reservoirs and stratigraphic traps. Also, we can see on the flanks when are the highs and when are the wells, and the central part, which is actually more calm. The reservoirs actually are supported by Calasu well, which is the only well that we have close to this area of the Magdalena fan development. So we can identify there, or they were identified actually, several important reservoirs or sand zones from Anadarko 2016. So basically from the upper Miocene to lower Miocene and upper Pliocene, we got several important areas with good petrophysics characteristics as a reservoir, showing us that are good reservoirs. Seal, regarding the sealing regional terms, we can tell that late Eocene to late Oligocene can be a regional seal. Basically, it was a bathyal marine environment from Paleocene to Oligocene along the basin. So basically that can be a really good regional seal in case that it could be some accumulation of the hydrocarbons during the Cretaceous, in the Cretaceous volcanic sandstones. This is how in the seismic we can see it in the pink. So it's basically a reflector that we can follow along the basin. The depth range from 9,000 to 48,000 feet approximately, 3 to 10 seconds two-way time. Then we can talk about early to middle Miocene. During that period of time, actually, despite it was increasing contribution of the offshore sediments, basically, as we see it, it was mainly the first stages of development of the Magdalena Delta and Magdalena Fan. So there was not much impact or much sedimentation, important sedimentation inside the Colombia Basin. So basically we got bathyal deep sediments in most of the basin during the period of time. So we consider that can be also a regional seal that could work really well in case that we got early accumulation. So in the younger sediments and in the older sediments as the Cretaceous. Basically, there are clay, marl, limestones, some volcanic ash. That was according with what we found in, or what we interpreted from the wells DSPD 153 and DSPD 151. Something interesting about the seal rock is that we could map a really important, as you can see here, a really important MTC that got a regional configuration, basically. Most of the MTCs in the literature are chaotic material, as we know. There's mass transport material that basically got low reservoir properties. So basically, we believe that this can be or can work as a seal for certain areas in the basin. And regarding traps, what we see regarding traps in our interpretation, basically, we could identify, in terms of structural traps, we could identify 5 provinces, structural provinces. So we got the central province, which is basically normal faulting, where we can see gravels and gravels generating the accommodation space. There are parallel to the Mid-Oceanic Pacific Ridge, and the direction of the extension of the movement of the plate that was towards northeast. And also in that area, in younger sediments, we can see some transtensive faulting as well, as we can see right here. So we got basically all the normal faulting in the basement, Cretaceous with syntectonics sedimentation in chafed configuration, and then we got more steep faults, which are actually a sun reactivation of this extensional gravels and horse that were getting some transtensive kind of configuration. We have it on the flanks, province 2, 3, and 5. Basically, province 2, 3, and 5, as you can see here, we can see province 3. Here we can see province 2. There are basically highs in areas where faulting was not that important, and the whole sedimentary package actually was more condensed somehow. We got province 5, which is the little parts or the small parts that we got from the folding belt of Guajira and Sinu, and they're already being discussed in the other talks. Stratigraphic traps, we come back to this. So basically, we think that most of the most important stratigraphic traps are related to the lower and upper Magdalena Fan where it's possible to identify channels, levees, amalgamated channels, among others. Direct hydrocarbon indicators. Regarding direct hydrocarbon indicators, as we discussed already, Miocene, especially late Miocene and Pliocene, are the most, let's say, regional and most important and regional perspective reservoirs in the basin. And also, when we applied some trace envelope, we could identify some bright spots in these areas. So it seems that it's some gas chimneys that are telling us about probably some insights about the properties, reservoir properties of those levels, late Miocene and Pliocene. And we mapped those bright spots. So basically, for the late Miocene, this is the distribution of those late Miocene bright spots. As you can see, basically they are on the deepest part of the basin, right? And for the Pliocene bright spots, the location is similar. However, it's important to see that this is 2D that was mapped with 2D seismic, but it's giving us insights of some direct hydrocarbon indicators. Finally, I'm gonna take you through the place that we identify. So we could identify 14 places in total. We describe, I identify which kind of place each element of the petroleum system that we believe is in those places. Some examples in there indicate that it's example or it has been already drilled, not in Colombian basin, but at least in the basins nearby. Analogs around the world and which kind of play that was. So the first one is the Upper Magdalena Fan Channel Complex. Basically, this is stratigraphic, hypothetic, and as an analog, Libonolo field in Congo is a good analog. Play 2 is truncation against basement. So what we see here is this high impedance reflectors actually are going against basement in those holes and gravens, and in the case that as well DSPD 153 is showing, Cretaceous sediments got some volcanic sands. In the case that actually they're working as a reservoir, we got a potential there in the on lab terminations against basement. Of course, stratigraphic is hypothetic, and the analog is Tanam field in Tanzan, Mongolia. Plate 3, anticlines by differential compaction. So we got some important highs in the basin that is structural, is hypothetic, Fortis field in the North Sea is a good analog. Plate 4, anticlines imbricated in the Caribbean South deformed belt. This was already discussed, but we put it here because we got a little part or a small part of the deformed belt. So it's a structural analog Niger Delta in Nigeria. Plate 5, anticlines associated with transtensive faults. So basically, all those faults that are neogene sequence that are transtensive, we believe that can be creating some interesting structures that we can see. This is structural, hypothetic. The analog is Los Angeles Basin field. Plate 6 is filling in gravens. So basically, Cretaceous in tectonic sediments is a stratigraphic, hypothetic, and Gannet field in the North Sea, UK can be a good analog. Plate 7, paleo high basement with carbonates. In some of the most important paleo highs that we got in the seismic in the area, the deepest part, we believe that it could be at time the right condition to carbonate development. This is a structural, hypothetic, La Perla field, Venezuela is the analog. Plate 8, paleo high with Miocene sandstones. It's a structural hypothetic analog. Chuchupa field, Colombia is the closest as analog that we have. And as you can see, we got some good examples in these two lines there. Frontal splays that we could identify during the interpretation, basically in the lower, the distal part of the Magdalena fan that can be that could be identified in the seismic. This is basically a stratigraphic, hypothetic, and the Girasol field in Angola is a good analog. The MTC that we talked before, in case, as I said before, literature is showing that a really small percentage of the NTCs that have been drilled by accident actually in the world got good properties as a reservoir. However, it could be the case. It's definitely something that has to be drilled, as is quite got an important extension in the basin. So it's a stratigraphic, hypothetic, and the one of the few cases in the world is CNC field. Yes. Play 11 subthrust anticline basically is something that is in the border between Colombian Basin and the deformation belt of Guajira and Sinu, structural deformation belt. This is proved, and the analog is Kronos, Colombia. Backthrust anticline. This is it's a structural. It's also right in the border between the formation belt and the deeper part, Colombian Basin. It's a structural without proof. Analog can be Medfani field in Indonesia. And 13 is natural fractural reservoir, anticlines the form belt in Riohacha field. It's a structural, it's hypothetic, analog Banch Ho field in Vietnam. Norma faults in tertiary sediments is basically all these structural neogene structures in some cases that are coming or are connected with the basement. This is a structural hypothetic. An analog is a Skua field in Timor Sea. And finally, according with that, we try to get some risks unexplored areas regarding all those elements of structural elements of petroleum system that we could identify in the seismic. Basically, we got three different areas. As you see, the highest risk is the number 3. When we got all the highs, we got a really squeeze or condensed sedimentary sequence, and most of the sedimentation in those areas actually was bathyal deep marine sediments. So the potential of having their important structures is low, but also to have important reservoirs is low as well. And then we got number 2 in yellow. Number 2 is actually the more distal part of Magdalena fan. So actually some channels, really deep channels, and frontal splay can actually go into that area. So it's a question mark there regarding reservoir especially, but it could be. And then we move into the green, that is low risk, where we believe that actually reservoir is the deep, especially in this area, the deepest part of the basin, or the deepest thickness of the sediments. So we know that is an important pod in the generation. Additionally, we got more direct influence and development of sedimentation related with the development of Magdalena River, Magdalena fan. Therefore, we're going to have better reservoirs. We got potential, we got the structures, potential structural traps, but stratigraphic traps, and also a mixture between both. And this is what I have to show you today. Finally, this is just to have into mind, this is a stratigraphic graph in the basin. We have here southwest, close to Magdalena fan, and this is towards the northeast in the shallow part. As you can see there, sedimentation, especially Cretaceous to early Eocene, is basically deep marine, as we already discussed. So in these areas, especially Cretaceous sediment, we're going to have all the source rock, some of the main seal in the area. And once we're moving close to the Magdalena fan, where we have the most important reservoirs, especially stratigraphic and structural traps, and most potential for accumulation. And once we move into the higher parts of Beata Ridge, for instance, there we have still some deep abyssal sedimentation, marine sedimentation. 30 minutes. This is everything I have to tell you. Thank you very much. I'm leaving you with Cesar Mora, who is, I think, is going to make a great wrap up of this session.
Okay, good morning, everyone. Thank you, Ruben. Are you seeing the Google Earth?
Cesar, we see in the Google Earth perfectly.
Okay, thank you. Thank you. Okay, right now, to close the presentations, I'm going to show a brief summary of the results that we have, that we got from the ANH, from the piston core surveys in the Caribbean basins. This will be just a summary about the main points we believe we have to keep in mind in order to classify the prospectivity of these basins. In general, this is really important because for so many surveys, exploratory surveys in this basin, people was always thinking in gas, thinking in this basin like a gas province, like a gas-prone province, and also thinking in biogenic gas, especially biogenic gas. And we believe that we have the option to change that scope, to change that way to see the exploratory opportunities in the basins. Why is this situation about the biogenic gas? It is because we have the only field we have is a huge field with almost 7 TCF. And this is an accumulation, a big accumulation where, as you can see here, 97%, almost 98% of the gas is methane. And also, this methane has a light isotopical composition. And according to the interpretation, the classical gas interpretation, this relation between the composition of the gas and the isotopical composition of the gas of the methane correspond to mixing or biogenic gas. What happened with this? 20 years ago, 22 or 23 years ago, was some people from the BASIP in France were working a lot about to research about this kind of accumulations, because it's not easy to explain a huge field just coming from the biogenic processes. And then in Colombia, Competrol was working on that. The samples, the gas samples from Chuchupa and Ballena were analyzed again. Victor Ramirez, that I think is here, was the director of that survey. And here in this graph, you can see another kind of scope for that composition. According to this, we can have this kind of situation, the same composition of the gas and the same isotopic composition of the methane, just because we have a secondary cracking of oil. That means we have the option to tie this kind of gas with a thermogenic process, with a petroleum system, and probably the main consequence of this is that if you have that gas, probably in some part of the basins, you are going to have liquids hydrocarbons. Probably you are going to have all the spectrum from the oil window and gas window. That's the main point. We have 20 years working with this idea, but unfortunately, we don't have discoveries to prove that. Then we had to wait for someone that could find this oil. I'm going to talk again about this and to compare the results with Perla in a few minutes. Now, I'm going to present the main points that we believe are important in order to classify this basin as a thermogenic geological province. The first one will be this information about the Sinu offshore, where you can see here the results of the piston core survey. You can see, according to this legend, that we have a lot of evidence of oil and also evidence of gas. And I'm going to show you an example like this. This is the concentration of heavy gases. You have here butane and pentane, and here ethane and propane. You can see that these green points corresponds to thermogenic gases. Remember that the methane could be related with biogenic or thermogenic processes, but the heavy gases are related in general with thermogenic. It's not possible to have these kind of gases, or it's very, very, very difficult to have these gases related with biogenic processes. Then these kind of results were found for so many of these surveys. We analyzed results for more than 1,000 piston core, and we found, according to the reports, evidence of thermogenic in at least 140 piston core, which is very important. Is something around 15% of the samples. That's one of the examples, and we have that kind of behavior in so many of these piston cores. Also, we have in this area something very important. This is coming from the BP survey 25 years ago, and here they found a black oil. They found an oil in a piston core sample, and something very important is that they found evidence of tertiary soft rock. They found this oleanane, and they found a lot of C29 sternes, which is very common for marine deltaic soft rock. And the oleanane, usually we interpret that as a tertiary contribution. That means that we have the option, like in the onshore basins, to have at least two soft rock intervals, one for the Cretaceous and another one from the tertiary, that right now we are thinking that could be the Eocene. And why we are thinking in the Eocene? Because we have new information from the onshore basins, and also we are integrating information from the Nicaragua offshore. Then we believe that in the future we are going to have more and more information to prove that this soft rock interval really is there. Okay, the other important point that we have in so many of these samples are related with the presence of thermogenic hydrocarbons. Here you can see a gas chromatography Normally we have hydrocarbons, the heavy hydrocarbons are related with the organic matter, with the recent organic matter. But these light hydrocarbons are related with thermogenic, with migrated oil. And that's very common in this, in some of these, we have this thermogenic hydrocarbon. This is a proof, this is a fact. We have thermogenic hydrocarbons there, and it's very important to recognize that, because this is a basin where we need to get all these small amounts of oil and put it together in order to keep the option for the exploratory surveys to find oil, to find liquid hydrocarbons. Okay, now I'm going to show something very special for the Cartagena area. Here, Ekion was working with the geochemical survey for piston core, and they found very interesting things. The first one was the presence of diamondoids in a very high concentration. The diamondoids are organic compounds that are related with thermogenic processes. We need the soft rock interval at the end of the oil window, beginning of the gas window, in order to have that compounds, that kind of compounds, and especially that amount of diamondoids. That's very important. And here we have a correlation with the diamondoids that were found for Ecopetrol 15 years ago. You can see the amount, the huge amount of diamondoids that Ekion found in the Cartagena area. And also they found, using biomarkers study, they found strong evidence of biomarkers that are related with tertiary source rock, that are related with thermogenic process, that this kind of biomarkers can't be related with biogenic processes. This is one of the main surveys, the most important surveys in the area. This is the Competrol Survey 15 years ago, and Ecopetrol found very, very, very important things. The most important was that they found oil. They found oil that here you can see a correlation, a biomarker correlation between one of these piston core samples, a Cretaceous oil from the Gulf of Mexico, and a Cretaceous oil from the Middle Magdalena Basin. And you can see a very strong correlation. This is a black oil that could be related with a Cretaceous source rock. Then this and the BP oil could represent the evidence of these two source rock intervals. The other important point for the Competrol survey was that most of the gas was thermogenic. The isotopic composition of that gas was thermogenic. Typically, thermogenic, we don't have for that samples the options to interpret it as a biogenic in the same way we can do with Chuchupa and Ballena. And also they found a lot of diamondoids. I show you the next cross plot. Then if you put everything together with this, you have oil, you have diamondoids in more than 80% of the samples, and you have in most of the 90% of the samples thermogenic gas. The isotopic composition of that gas is thermogenic, it's not biogenic. And finally, I'm going to show you the information. We are trying to correlate Chuchupa and Ballena, which is our gas field, with the Perla field. You know that Perla field is located in Venezuela, but it's very, very important to compare these two results. Excuse me. What we have in Perla? The main point in Perla is that the gas is coming from primary cracking. Remember that the gas in Chuchupa and Ballena is coming from secondary cracking. It's oil that were cracking to gas. And here we have gas coming directly from the source rock, directly from the kerogen. That's the main point, the first point. And the second one is that they have condensate, and they have an important amount of condensate. And remember that the condensate is related with the end of the oil window. We need that source rock on that kind of maturity level in order to find the condensate. Then how can we explain this difference? Which one could be the main difference way to explain the difference between Chuchupa and Perla? There is an easy way. There is a simple way. It's just the maturity level of the pod active of source rock. With that change, we can explain that difference. And again, this is very important because we have the option to find in these basins the same maturity level in some areas. Then we have the option to find additional hydrocarbons that could be obviously liquid hydrocarbons, could be condensate, or could be black oils, because we know we have black oils. And those are the main kind of evidence we have, and we believe that according to this, is very important to keep in mind that we can classify this geological province as a oil-prone basins where we have all the spectrum of the hydrocarbons that you can find from the oil window and from the gas window. Until now, we have just this field with gas coming from secondary cracking, but we have the opportunity. We have the option to find the liquid hydrocarbon, that the hydrocarbons are waiting for someone. An additional information that is very important is that in Chuchupa and Ballena, from the production facilities, there is condensate. They have condensate, small amounts of condensates, but that's a proof of that, the interpretation. That's a proof that the gas are related with the thermogenic system. And finally, I'm going to show, excuse me. The Calamar well evidence. On that well, we have, that's the only liquid hydrocarbons we have from wells in these basins. But it's, again, it's just one evidence, but it's very, very important. It's a strong evidence. We have their condensate. It was present in the cuttings. You can see here the gas chromatography is a strong evidence of a light hydrocarbons that could be classified as a condensate. You can see the fluorescence of that hydrocarbons. Then in the wells, that's the only evidence. It is very small, but we have to include that because we can't explain that from a biogenic process. In summary, we believe that the biogenic model obviously is there. We have biogenic gas. Of course, we have, especially in the shallow reservoirs, we are going to have that. But also, we have a strong evidence of thermogenic hydrocarbons And the main consequence of that is that we have the opportunity to find liquid hydrocarbons, and especially light hydrocarbons, condensates, black oils, and condensates. Okay, that's the summary I have for today. If you have a question, we can check the chat. Thanks a lot for your time.
Okay, Cesar, thank you very much for your presentation of today. And if you got any question, maybe to Ruben, to Angela, or to Cesar, we'll be glad to read it and to answer it. We got a couple of comments that were made during the presentation, and I reckon it's worth it to at least read it. We got a first one that is commented by Diego Lafa. He said that the extensional faults of the basement are formed as the oceanic crust of the Caribbean is being subducted below South America. He recommended not to call it basement, as it isn't a static rigid surface, but a very good dynamic oceanic crust. That's a very interesting point, and that there are some previous extensional fissures on the oceanic crust related to oceanic crust processes such as aborted mid-oceanic ridges and extension during the plateau stage. He recommended to see Gomez Garcia et al. 2021. And he said there are plenty evidences of flat slab subduction, such as the active earthquakes, the slab evidence in the seismic tomography, very active tectonic uplift of basement core ranges. Daniel Regona asked during the presentation that if Cesar and Victor, and they are already answered, could you please mention what well has penetrated the Cretaceous other than the ODP or the DSDP? So Cesar answered that the San Jose one. Victor Ramirez said the PGG one, and asked Juan Pablo Ramos if those reports you use in your presentation are public. That's the last one question that we got. Okay, I think that question from Juan Pablo will be answered later. In terms that we are not sure if that information is public at all. So I like to thank everyone of the attendees for today, and as well for the speakers. I would like to thank Ruben, Cesar, and Angela for the presentation of today. And we'd like to invite all of you to don't forget to attend the next Friday talk about the undeveloped and already discovered reservoirs that will be carried out by the ENH. We'll be presenting the Middle Magdalena Valley, the Lower Magdalena Valley, and the Sinu San Jacinto opportunities. So see you all next week, and I hope you enjoyed today's presentation. Thank you very much.